Imagine you wake up and check the news. Every coastline on Earth has moved inland. Whole cities you know are underwater now. Sound impossible? Scientists say it is not. All that water is frozen, right now, waiting. This video asks one giant what-if question. What if every glacier, ice sheet, melted completely? You're about to see how far that goes. Stick around. The answer will surprise you. Quick thing before we dive in together. Like, subscribe, and drop a comment below. Here's the plan for this journey together. First, how much ice actually exists today? Then, how high the water would rise. Next, what happens to weather and animals? Finally, the strangest surprises hiding in ice. Ready? Let's start with the ice itself. Antarctica holds most of Earth's frozen water. Picture a layer of ice, miles thick. That's taller than most mountains you know. Glaciologists drilled deep cores to measure it. Richard Alley has studied these ice cores for decades. Each stripe of ice records an ancient year. Antarctica alone could raise seas 58 meters. That number alone is hard to imagine. Below the ice sits solid rock and mountains. Some of that rock has never touched open air. But Antarctica is only part of the story. Let's look at the ice up north. Greenland carries its own giant ice sheet. It's the size of Alaska, frozen solid. This ice alone holds 7 more meters. Every summer, researchers watch it melt faster. Streams of meltwater carve blue rivers through ice. Some of that water crashes deep below. Satellites track this melting from high above. NASA's satellite missions measure it every month. Now picture the ice floating at the North Pole. This ice already floats on top of water. So melting it won't raise the sea much. Still, this ice matters more than you'd think. White ice reflects sunlight back into space. Dark open water absorbs heat instead, warming faster. Losing this ice speeds up warming everywhere. It's a cycle scientists call a feedback loop. Indigenous Arctic communities already notice the changing ice. Beyond the poles, glaciers cover every continent. Mountain glaciers feed rivers millions of people drink. The Himalayas alone are called the third pole. If these glaciers vanish, rivers could run dry. Andean communities already ration melting glacier water. Alpine glaciers in Europe are shrinking every year. Together, all these glaciers hold real height. Small compared to the poles, but still enormous. Add it all together, Antarctica, Greenland, glaciers. You get one staggering number for sea rise. More than 60 meters of water, total. That's like stacking 20-story buildings underwater. Oceanographers and glaciologists calculate this using satellites, models. Sylvia Ull has spent her life studying oceans. Her research reminds you, oceans and ice connect. Together, this locked-up water could refill oceans generously. Now you know the number. Here's what changes. Picture your own city under 60 meters. Only the tallest towers would poke through. Everything else you know would be gone. This wouldn't happen overnight, but it would happen. Coastal maps would need to be redrawn completely. Let's look at exactly which places disappear. Coastal cities are built low, right at sea level. That makes them the very first to flood. Imagine your favorite coastal city, waterlogged and empty. Streets become canals. Cars become useless underwater. Subway tunnels fill first, deep underground and hidden. Emergency crews already plan for rising water today. Ports and harbors would need to move inland. Airports built near coastlines would need new runways. Bridges built for boats would sit half-drowned. Skyscrapers would become strange islands in open ocean. People would need entirely new ways to travel. Around the world, this pattern would repeat everywhere. No single country would be spared from this. Some places wouldn't just flood, they'd vanish. Low, flat regions are the most vulnerable of all. Much of the Netherlands already sits below sea level. Its engineers are famous for holding back oceans. but 60 meters would overwhelm even the best walls. Low river deltas in Asia would disappear entirely. Millions of farmers there depend on that fertile land. Island nations in the Pacific would lose everything. For their people, there would be nowhere left to stand. Historic coastal landmarks would need protection or relocation. New coastlines would form on every remaining continent. Picture a brand new atlas, completely redrawn. Some inland cities would become the new coast. Mountains and high plateaus would become the new shorelines. Entire nations might need to relocate their capitals. New port cities would rise on higher ground. Trade routes across oceans would need fresh maps too. It's a strange thought, geography itself, rewritten. But water isn't the only thing that changes. A melted world would also feel very different. Without reflective ice, the planet absorbs more heat. Average temperatures would climb noticeably higher worldwide. Hotter air holds far more moisture than before. That means bigger storms, heavier rain, stronger winds. Coastal storms would push seawater even further inland. Droughts would strike hard in other regions entirely. Wildfires could also increase in drier inland regions. Climate scientists like Katherine Hayhoe study these shifting patterns. Her work links melting ice to storms far away. Weather wouldn't just change, it would become unpredictable. Beneath the waves, something else would shift too. Cold, fresh meltwater would pour into the oceans. This could slow down currents like the Gulf Stream. That current currently keeps parts of Europe mild. Oceanographers warn a slowdown could flip that balance. Fish migration patterns would shift as waters warm. Fishing communities would need to adapt their routes. The ocean, it turns out, connects everything, everywhere. Now think about who actually lives on that ice. Polar bears hunt seals from floating sea ice. Without ice, that hunting ground simply disappears. Mother bears already swim longer distances for food. Walruses crowd onto shrinking patches of remaining ice. Arctic foxes and seals would lose their homes too. Researchers tag and track these animals every season. Their data shows a clear pattern: less ice, fewer animals. Down at the opposite pole, penguins face similar struggles. Emperor penguins need stable ice to raise chicks. Cracking, unstable ice can strand entire chick colonies. Krill, tiny shrimp-like creatures, depend on sea ice too. Nearly everything in that ocean food web needs them. Lose the ice, and the whole chain wobbles hard. Now picture the people who live along these coasts. Today, hundreds of millions live near rising water lines. Slowly, many would need to move to higher ground. Entire neighborhoods would relocate together over generations. Governments would need to plan new inland cities. Some places already practice this kind of planning. New jobs would emerge building the next generation of cities. It wouldn't be easy, and it wouldn't be fast. But humans have moved before and adapted before. Resilience, researchers note, is part of the human story. Still, this kind of change reshapes everything, everywhere. But melting ice hides an even stranger surprise. Permafrost is ground that stayed frozen for millennia. As it thaws, it releases gases trapped inside. One of those gases is methane, a strong warming gas. More methane released means faster warming still ahead. Scientists have even found ancient microbes inside old ice. Most are harmless, long dormant, and carefully studied. Old infrastructure built on frozen ground would also crack. Researchers monitor this closely, out of careful curiosity. It's less a horror story than an open question. The frozen past, it turns out, holds real secrets. So how fast could all of this actually happen? Not overnight. This would unfold over centuries. Antarctica's deepest ice could take 1,000 years. Greenland and mountain glaciers would likely melt sooner. Ice sheets respond slowly, but they do respond. Even a few degrees of warming still matters hugely. Every fraction of a degree changes the timeline. That's exactly why researchers track it so precisely. Every measurement helps sharpen tomorrow's predictions today. You might wonder why anyone studies ice so closely. Ice holds a record of Earth's entire climate history. That history helps predict what comes next, precisely. International teams share this data across every continent. The IPCC gathers thousands of these scientists' findings together. Their reports guide decisions made by governments worldwide. It's careful, patient work, built one measurement at a time. That patience is exactly what makes the science trustworthy. Here's the part that might surprise you most. This process has already quietly begun, right now. Sea levels have risen inches over the past century. Some island nations already build homes on stilts. Certain cities now flood during unusually high tides. Engineers are already designing flood barriers and pumps. Reservoirs and dams also track shifting glacier meltwater. None of this is science fiction anymore, really. The what-if is already becoming a slow what-is. So picture that morning from the very start again. The coastline outside hasn't moved. Not yet, anyway. But now you understand exactly what's frozen out there. Every glacier, every ice sheet, holds real potential. Scientists like Ali, Earl, and Heiho keep watching closely. Their careful work keeps this story from becoming reality. The ice is still there. The choice is ongoing. So next time you see ice, you'll remember this.